In March of 2020, every major airline on Earth grounded its fleet almost overnight. And somewhere in Derby, England, a company that doesn't fly a single passenger, doesn't own a single airport, and doesn't sell tickets to anyone, watched its revenue collapse faster than the airlines themselves. Rolls-Royce raised £2 billion in an emergency rescue offering. It cut 9,000 jobs. Its share price fell more than 80%. Here's the strange part. Nobody had canceled a single engine order. The engines Rolls-Royce had already built and delivered were sitting exactly where they'd always been, bolted under the wings of Airbus A350s parked in the desert. They just weren't moving. In Rolls-Royce's business, an engine that isn't flying is an engine that isn't earning a single pound. To understand why, you have to understand something most people get completely wrong about how jet engines actually get sold. When a normal company sells something expensive and complicated, a car, a piece of industrial machinery, they sell it once. The buyer takes ownership, and from that point forward, the buyer also takes the risk. The maintenance costs, the breakdowns, all of it belongs to whoever bought the thing. Rolls-Royce looked at that arrangement roughly 60 years ago and decided it didn't want any part of it, at least not for jet engines. Rolls-Royce, the third largest maker of commercial aircraft engines in the world, doesn't really sell jet engines in the traditional sense. It rents them out by the hour. When an airline buys an Airbus A350, the two enormous engines hanging underneath the wings are technically the airline's legal property. But for the next 25 to 30 years, almost everything that actually matters about those engines, the maintenance, the performance risk, the cost of every single shop visit, stays with Rolls-Royce, in exchange for a fixed fee paid for every hour those engines spend in the air. It's one of the strangest financial arrangements in modern manufacturing. A Rolls-Royce engine isn't really a product an airline owns outright. It's closer to a 25-year subscription where the airline supplies the airframe and Rolls-Royce keeps the metal alive underneath it. To understand why this model exists and why it very nearly destroyed the company in 2020, you actually have to start with the engineering itself. Quick pause. Before we go further, if you're new here, this is Jet Verdict, and we break down the hidden business and engineering decisions behind commercial aviation every week. Hit subscribe now so you don't miss the next one. The Trent family of engines powering the A350, 787, A380, and most modern wide-body jets is built around a design most engineers would call unnecessarily complicated, a three-shaft architecture. A typical jet engine, the kind GE or Pratt and Whitney build, has two concentric spinning shafts, low pressure connecting the fan to the rear turbine, high pressure connecting the compressor to the front turbine. A Trent has three, with the fan, intermediate compressor, and high pressure compressor each spinning independently at their own optimal speed. It's more efficient since every component runs exactly where it performs best. It's also far more complex to build and maintain. Intuitively, more shafts should mean more failure points and more cost. It does. But Rolls-Royce turned that complexity into a structural advantage none of its competitors could easily copy. The Trent XWB, which powers the A350, has a fan roughly 3 meters across with 22 titanium blades, producing between 84,000 and 97,000 pounds of thrust. And Rolls-Royce calls it the most fuel-efficient large aero engine in commercial service, burning 25% less fuel than what it replaced. That detail matters enormously to everything that follows. Back in 1962, a British engine maker called Bristol Siddeley had a problem. Its Viper turbojet, originally a cheap, disposable engine for target drones, kept needing unexpected maintenance once repurposed for actual business jets. So Bristol Siddeley invented a contract that had never really existed in aviation before, telling operators of the de Havilland 125 something radical. Don't pay us when the engine breaks. Pay a fixed amount for every hour it flies and we'll handle everything else. They called it power by the hour. When Rolls-Royce acquired Bristol Siddeley in 1966, it inherited that structure, and over the following 4 decades, industrialized it, rebuilding its entire commercial aerospace business around it. The terms are simple once you understand them. The airline pays a fixed dollar amount per engine per flying hour. In return, Rolls-Royce takes on full responsibility for performance, scheduled maintenance, unscheduled repairs, replacement parts, and every shop visit for the engine's entire operational life. The airline gets a predictable cost of ownership. Rolls-Royce gets a 25-year revenue stream tied to one variable: how often those planes are actually in the air. What makes this model possible and also makes it so dangerous is buried in the engineering itself. Modern jet engines operate at temperatures that should, by any normal material standard, be impossible to survive. The turbine inlet temperature inside a Trent, where burning fuel meets the first turbine stage, runs between 1,500 and 1,700 degrees Celsius, hundreds of degrees hotter than the melting point of the nickel superalloy the blades are made from. Those blades survive only because they're hollow. Cooling air bleeds from the compressor and forces through internal channels, escaping through tiny pinholes on the blade surface, creating a thin film of cooler air that keeps the metal from melting. Every blade is also coated in a ceramic thermal barrier layer, roughly as thick as a sheet of paper, which does most of the actual heat shielding. This level of materials engineering isn't something you can maintain casually or outsource cheaply to a third-party shop. The tooling is entirely bespoke to Rolls-Royce. The training takes years, and the supply chain for genuine replacement parts runs directly through Rolls-Royce alone. On top of that sits the data layer. Every Trent engine currently in flight transmits real-time performance data by satellite back to Rolls-Royce's operations center in Derby, England, where roughly 170 engineers monitor thousands of engines simultaneously, watching for early warning signs before a small problem becomes an expensive one. This engineering monopoly is exactly what lets Rolls-Royce dominate the hidden majority of its entire business, the aftermarket. In 2023, its civil aerospace division generated around £4.6 billion in aftermarket revenue alone, roughly 72% of it from long-term service agreements like this one. The initial engine sale happens once. The maintenance contract that follows runs for 25 to 30 years, and across that lifespan, ongoing service revenue completely dwarfs the original hardware sale. The aftermarket isn't a side business, it is the business. Selling the engine is just the entry ticket. The Trent fleet today is overwhelmingly locked into this structure. Roughly 90% of installed Trent engines are covered under one of these long-term care agreements, and effectively, 100% of existing customers re-enroll for their next aircraft order. As of early 2024, Rolls-Royce had 248 active long-term service contracts covering roughly 4,000 large commercial engines, a quarter-century of guaranteed revenue indexed to one number: total flight hours flown. The entire model only really breaks down if airlines simply stop flying. Until 2020, that was purely a theoretical risk. It had never actually happened at global scale before. Here's where the story gets strange even before the pandemic hit. Back in 2016, on brand new 787 Dreamliners operated by All Nippon Airways, Rolls-Royce, engineers found the intermediate pressure turbine blades inside the Trent 1000, a different Trent variant built for the Dreamliner, corroding faster than anyone expected. Up to 500 engines were affected. At the worst point in 2019, 44 wide-body aircraft sat parked on tarmacs waiting for replacement blades, and the FAA cut the 787's certified over-water range from 330 minutes to just 140, gutting one of the aircraft's central selling points overnight. Under the power-by-the-hour structure, every grounded Trent 1000 was entirely Rolls-Royce's problem to fix and its bill to pay. Between 2017 and 2023, the company absorbed £2.4 billion in charges tied to fixing that durability problem alone. Then, in March of 2020, the entire global commercial aviation industry stopped moving almost simultaneously. Wide-body flight hours, the exact metric Rolls-Royce's entire revenue model was built around, fell by roughly 3/4 within a matter of weeks. Every long-term care contract the company had ever signed technically remained in force. None of them were generating any actual payment. The exact model that had spent 60 years transferring maintenance risk away from airlines and onto Rolls-Royce was now, for the first time, transferring an unprecedented industry-wide crisis directly onto Rolls-Royce's own balance sheet. In October of 2020, the company raised £2 billion through an emergency rights issue, added a £1 billion bond and a £1 billion bank loan, bringing total emergency liquidity to roughly £5 billion. It announced 9,000 job cuts. Its share price collapsed from over 700 pence in early 2020 to below 100 pence by that autumn. Then something almost nobody predicted happened. Those long-term care contracts hadn't actually disappeared when the fleets got grounded. They'd simply paused. Every A350 and 787 sitting motionless in desert storage in 2020 represented a deferred Rolls-Royce invoice, not a canceled one. When flight hours eventually came back, they came back against contracts already signed years earlier, on fleets Rolls-Royce had spent decades locking in. By 2024, the company reported an underlying operating profit of £2.5 billion. In 2025, that grew to $3.5 billion, with civil aerospace margins reaching 20%. The share price climbed past £11 by mid-2025, a roughly tenfold recovery from its pandemic low, and the company started buying back £1 billion of its own stock. Same underlying model, simply different flight hours running through it. So the real story of Rolls-Royce was never really about building jet engines. It's about figuring out, decades before anyone else in the industry caught on, that the engine itself was never the product. The flight hour was the product all along. 60 years ago, Bristol Siddeley solved a maintenance headache on a modest business jet by inverting the contract. Charge per flying hour instead of per part, absorb the risk, keep the relationship for decades instead of one transaction. Rolls-Royce inherited that idea almost by accident, scaled it across the most complex turbine engineering ever built, and constructed a business where its own interests and its airline customers' interests are almost perfectly aligned. Both sides win as long as the engines keep flying. The catch? The part almost nobody fully appreciated until it actually happened is what occurs when the engines stop flying entirely. The pandemic answered that question with brutal clarity in 2020. The recovery answered it again, just as clearly, by 2025. The next time you're boarding an A350 and glance out at the engine under the wing, remember what's actually happening underneath that casing. The airline technically owns the turbine, but Rolls-Royce, very quietly, owns the next quarter century of every revolution that engine makes. If you want to see how Rolls-Royce is defending this exact model against GE's growing dominance on the 787 and 777X, that story is already on this channel. Subscribe to Jet Verdict to keep following the hidden economics that actually run modern aviation.